Okay, this is question 8. So we have a quartic polynomial. We're first going to subtract 63 from both sides. So we can set this equal to 0. And if we look at this, it almost looks like a quadratic, except that we're going to the 4th power in our first term and squared in our second term. So what we're going to do is we are going to substitute in a u that's equal to x squared. And when we do that, we can rewrite this as u squared plus 2u minus 63 equals 0. And now we can factor that. Here's u, and that's going to break into u plus 9, u minus 7, which gives us solutions of u equal to negative 9 and u equal to positive 7. We need to go ahead and substitute in now our x squared for u. We get actually x squared equal to negative 9, and we get x squared equal to 7. Solving for the x squared equal to negative 9. Well, we have x squared, well, we're going to square root both sides. And so we would end up with x equal to plus or minus square root of negative 9, which is a complex number. So I'm going to go ahead and break this into plus or minus square root of 9 and square root of negative 1, which is going to give us plus or minus 3i. So there's our two complex roots. And then with x squared equal to 7, square root both sides, we get x equal to plus or minus radical 7. So there's our two irrational roots. We get two irrational roots and two complex roots for a grand total of 4 roots, which is what we're expecting to start with. Question 9. This one we can actually factor by grouping. So I'm going to group the 2x cubed and the 8x squared together, and we'll group these two together. In the first grouping, we're going to factor out a 2x squared, and we'll be left over with an x minus 4. And in the second grouping here, I'm going to factor out a 5 and be left over with an x minus 4. And so altogether, I'm going to end up with an x minus 4 times a 2x squared plus 5, which these are being set equal to 0. All right, which actually, I went ahead and solved those in my first version, but since it just says factor, we can just leave it right like this. We don't have to set it to equal to 0. But both of these, we could set each of these parentheses equal to 0, and that would be, we could solve both of those. The 2x squared, well, the x minus 4, we get an x equals 4, and the 2x squared plus 5, we're going to get some imaginary solutions there. Okay. Part 3, no calculator graphing. So given the polynomial f of x below, what is the smallest possible degree of f of x? First thing that I do notice, based on the end behavior here, it's going to be an even function. We're going to have an even number of roots. Okay. Second, I've got a bounce here at negative 5, so there are going to be 2 roots here, minimum of 2 roots. I suppose there could be 4, but we're looking for the smallest possible degree. We have a single root here, and it's going to be definitely a single root because a a triple root would have a bend or a kink as it goes through that root. This is just going straight through. So there's one root there, and same here at 6. There's one root at 6. So counting out our total roots, we'd have 2, 3, and 4. So the smallest possibility would be 4 roots, which matches what we predicted. This is even. Okay. Question 11 says if f of x passes through -1, 3, give the equation for f of x. Okay. Well, we have our roots, and so we could start our equation like this. F of x equals, and we have x plus 5, and that's a double root, so we have squared there. We have a root at 2, so we have a factor of x minus 2, and we have a factor of x minus 6. Okay. However, there could be some constant, some multiplier here that we don't know, okay? An a value that we need to solve, and that's what we're going to use this point here to solve for a. So what we're going to do is we're going to set f of x equal to 3, and we're going to plug in -1 for x. It's -1 minus 2, and -1 minus 6. And we're going to solve for a. Well, when we multiply that all out, we get 4 here, and 4 squared becomes 16. We're going to have a -3 here, and we're going to have a -7 here. -3 and -7 gives us 21. We're going to have to do 21 times 16. So we'll do that here since you guys aren't going to have a calculator. It's going to be 6 and 12, 0, and then that's going to be 21. Add those together, and we're going to get 336. So our equation is now going to look like, well, 3 equal to a times 336. We'll divide both sides by 336, so we get a equal to 3 over 336. Noting my shortcut, we want to see, is this actually able to simplify this? Well, 3 plus 3 plus 6 gives us 12, which means it's divisible by 3, so we can divide both the numerator and denominator by 3. And when we do that, we get 1 over 112. And so our final equation would look like this. F of x equals 1 over 112 x plus 5 squared, x minus 2, and x minus 6. And we don't need to multiply that, we'll just keep it in intercept form.